So, hello everyone, myself Dr. M. Vinayak, working as assistant professor from the Department of Agriculture Engineering, Aditya University. Up to last class, we have seen the different types of seed metering mechanisms as well different furrow openers. So, today's class we need to discuss the seed drill calibration. So, this seed drill calibration is very important for manufacturing of seed drills. Okay. So, let us look on to the learning outcomes of the today's lecture. So, define the seed drill calibration as well as we need to discuss the zero till drill as well, we can discuss the strip drill also. Okay. So, here seed drill calibration nothing but laboratory testing of seed drill to determine the rate of seed delivery is called calibration of the seed drill. So, here before going to the main field for sowing purpose, whatever the manufacturer was developed a product, we need to test. So, the testing of seed drills in laboratory level, so that is called as a seed drill calibration. So, during the process of testing, we need to maintain the optimum sowing rate. Okay. So, we need to maintain the optimum sowing rate as well as how much seed was delivered throughout the seed drill. Okay. So, suppose this one is a seed drill. So, here some furrow openers are there 1, 2, 3, 4, 5, 6, 6 furrow openers are there. From the 6 furrow openers, how much seed was discharged? That is also we need to calculate during the process of seed drill calibration. So, another point is the percentage of the variation. So, suppose this this seed tube was delivered 100 grams of seeds. Okay, this seed was delivered 90 grams and this seed tube was delivered 100 grams. So, during the process of seed calibration, uneven seed outcomes will be received from the seed conveying tube. So, the percentage of variation should not less or more than the 7%. Okay. So, we need to maintain that value. For that purpose, we need to do the seed drill calibration. Before going to the seed drill calibration, we need to calculate the width of seed drill, that is a W. W nothing but M into S. So, here M nothing but number of furrow openers and spacing between the two furrow openers. So, here spacing between the two furrow openers nothing but this one is a spacing. So, some of the manufacturer they can maintain 30 to 45 centimeter spacing between the two furrow openers. Okay. So, here number of furrow openers 1, 2, 3, 4, 5, 6, 6 into 30 centimeter. Okay. So, 180 centimeter, that is the total width of the seed drill. Okay. And find the length of strip land L for an area of 1 by 25th hectare, taking the width of sowing as a cover of 1 by 25th hectares. So, suppose this one is a land area. From this land area, we are taking the 1 by 25th part. So, that is the meaning of this sentence. We are taking the 1 by 25th area. To cover the 1 by 25th area, so that is a L. How much length was there to cover the 1 by 25th area? L equal to 1 by 25 into, so here we need to convert this hectare into the meter square, that is a unit conversion 1000 meter square into, that is width of seed drill in terms of meters. So, here finally length of strip land 400 divided by W. Okay. So, here we are taking the 1 by 25th area, that 25th area hectare was converted into the in meter square. Okay. Here already we know the width of seed drill, we need to divided this strip area with the width of seed drill, that is a meter. So, from this one meter square and meter cancel, so that we can get the length of strip land L equal to 400 divided by W, right. So, here we need to cover the length of strip land. So, that is a formula of L equal to 1 by 25th into 1000 into 1 by W. So, here the final formula is L equal to 400 divided by W. So, in terms of meters, to cover the one length of strip land, how many revolution was required, we need to calculate. So this one is a ground wheel. Okay, so it will be provided in front of the seed drill. To cover this 1/25 area, how many revolution was required to cover the strip of land? Okay, so that is we need to calculate. So this revolution will be depend upon the perimeter of this ground wheel as well as, okay, so here can depend upon the perimeter of the ground wheel. So that is L equal to pi dn equal to 400 divided by W. Okay, to cover the one length strip land. So how many revolution was required, we need to calculate. To determine the number of revolution of the ground wheel of the seed drill required to cover the strip of length L meters. So that is L equal to, actual formula is L equal to 400 divided by W. So here L nothing but pi d n. So how many revolution was required to cover this amount of area, that is 400 divided by W. Finally L equal to 400, okay, L equal to 400 pi d by W. Okay, so this one is a formula regarding number of revolutions. Okay, so next we can before going to the filling of seed into the seed drill, so we need to mark the ground wheel, make a mark on ground wheel corresponding to the convenient place of the body of the seed drill. So to help it will help the counting the number of revolution of the ground wheel. So before going to the fill the seed into the hopper, simply marks on the seed drill as well as convenient place on the ground wheel. So to rotate the freely ground wheel, so fill after marking we need to fill the seed into the seed hopper. Okay, so for collection of seed drill, each and every boat tag with the polythene bags. Okay, so after that we need to rotate the ground wheel for one revolution. So similarly we can take the readings up to 10 revolution, 20 revolution, 30 revolution. For 10 revolution, how much length was covered? So that is a length of strip land, as well as for length of strip land, how many seed was collected from the polythene bags. So that will calculate. Okay, so here already we know the length of strip land. So length of strip land nothing but here formula, above formula is there, and already we know the diameter. So how much seed was collected for 10 revolutions, that will know by testing of seed drills, so that we can calculate the how much seed was required per hectare area. Okay, so here we by using the sticky belt method we can what you called calculate the multiple index and missing index also. Okay, so if the one place we need to maintain the required spacing between the seed to seed. So at a one place can maintain the, for in if case at a one place the n number of seed will be deposited, that is called as a multiple index. Multiple number of seed was placing at a place, so that is one formula is there, that is called as a multiple index. So suppose we need to maintain the seed spacing like this, we need to maintain this type of seed spacing. In some situations the space between the two seeds will be increases. In this situation we can call it as a missing index. So here we can see the missing index clearly. Here one seed was missing, here one seed was missing. This one is the original spacing we need to maintain, but here we are maintaining this one, that is called as a missing index. So one small numerical is there. Okay, calculate the cost of sowing 1 hectare of land with the bullock drawn seed drill and the size of 5 into 22. So here 5 nothing but number of furrow openers 5 and spacing between the 2 furrow openers. So here we can calculate the width of seed drill, that is the 1.1 meters. the speed of bullocks is 3 km per hour. So that we can calculate the field capacity. So, okay, field capacity nothing but W into S by 10. So, here W nothing but width of seed drill, that is the 1.1 meter, and S nothing but speed 3, 1.1 into 10. So, here we can get the field capacity of this particular bullock drawn seed drill. Hiring charges of the bullock is 400 per day, and hiring charges of the seed drill is 200 per day, and wages of the operator is 400 per day of 8 hours. Okay. So, time taken to cover the 1 hectare. So, here can get the 0.33 hectare per hour. Okay. So, for cover the 1 hectare of land area, 0.33 hours was required. Okay. That is 0.33 hectare per hour. So, here time taken to cover the 1 hectare of area. So, here simply 1 by 0.33. So, that 3.03 hours was required to cover the 1 hectare of land area. So, here 0.33 nothing but here per 1 hour it was required, it will cover 0.33 hectare per 1 hour, it will cover the 0.33 per cover the 1 hectare of land area, almost 3.03 hours was required. Okay. So, cost of sowing, simply to sow the 1 hectare of land area, how much hours was required? 3.03. So, here already they have mentioned the different cost, like 400 bullock hiring cost, 200 seed drill cost, and wages of the operator is 400. And how much time was required? That is 3.03. So, how many operating hours? 8 operating hours. So, that we can get the 378.73 rupees per hour. Okay. This amount was required to sow the land in a particular area. So, this one is next one is a zero till drill. Okay. So, this machine was drawn by the 30 to 35 HP tractor. Okay. So, here consists of a 9-row unit, consists of a fluted roller feed metering mechanism. The type of furrow opener is T-type furrow opener into the soil at a desired depth. Place the seed in a moist zone. Okay. The ground drive will supply the power, sprocket and chain metering mechanism to the fertilizers also. The field capacity of this type of zero till drill is 0.35 to 0.5 hectare per hour. Sowing operation is possible to be advanced about 15 to 20 days as compared to the conventional method. So, the main purpose of the zero till drill here. So, in conventional method, after harvesting the crop, we need to go for the again ploughing operation and sowing operation independently we need to go. So, whereas by using zero till drill, so this one machine can plough the land with the help of T-type furrow openers. Okay. So, the rear side of this ploughing setup, they can provide the seed drill setup also, so that the ploughing operation as well as sowing operation will be carried out in a single pass. So, that is why here they have mentioned the sowing operation can be possible advanced about 15 to 20 days. Okay. So, here they completely eliminated multiple number of operation into the field. Okay. So, here we can see the one type of zero till drill. So, next one we can see the strip till drill. Okay. The main purpose of the strip till drill, so after harvesting the paddy crop, so many stubbles was left over the field. Okay. So, these are the stubbles after harvesting the paddy crop above the earth surface. So, we need to go for the next crop. What will be happen? Again we need to go for the tillage operation. Okay. So, sowing operation we need to go. So, in some cases after sowing also weeds will be emerged in between the row to row, that is unnecessary things. So here the main concept of the strip till drill is, so it will pulverize the stubbles. It will pulverize the stubbles, whatever the available of stubbles after harvesting the paddy crop. These stubbles will be cover the earth surface besides of the row. Okay. So here stubbles will be there. After passing strip till drill throughout the field, these stubbles will be pulverized and spread out throughout the surfaces in between the plants. Okay. So tillage and sowing operation will be carried out by using the strip till drill. It is used to the direct sowing of weed after harvesting the paddy crop. Okay, the machine consists of a 9-tine seed cum fertilizer drill with a rotary blade attachment operating in front of the furrow openers. So whatever the functions was doing in previous slides at zero till drill, same manner the strip till drill also followed. So whereas the stubbled material, whatever the stubbles was present over the land area, that stubble material will be spread throughout the surface of this land. Okay. The rotary attachment consists of a frame, 9 flanges welded rotor. Okay. So here the front side, the front side, the tillage setup will be there. Rear side, some rotary action type flanges was provided to pulverize these stubbles. So 9 flanges was provided rear side of this tillage setup. Tillage setup. Each flange consists of a C-type blades. Suppose here how many flanges is there? 1, 2, 3, 4. 4 flanges is there. These each and every flanges consist of a C-type blades. Power transmission unit consists of the rotary shaft, speed reduction gearbox and chain and sprocket. Effective width of output is 0.3 to 0.4 hectare per hour. So here we can see the complete picture of this strip till drill. Okay. So this one is a power transmission system. By using this ground wheel, we can transfer the power from ground wheel to here. We can provide the seed metering mechanism. So here one rotor shaft is there. This one is a rotor shaft. This one is a flange. Here 9 flanges will be there. For 9 flanges, C-type blade will be provided. These are the C-type blade. The main purpose of this C-type blade here to pulverize the stubble material present over the field and spread the pulverized stubble material throughout the field. So the rear side of this rotary setup, here the furrow openers will be provided. Okay, that furrow openers can open up the soil and sowing operations will be carried out. Okay, so here one gearbox will be provided to transmit the power from PTO shaft to this rotary shaft. During the process of rotating action, rotation action, we will cut the stubbles. Okay. So here some of the adjustment regarding the seeding and planting equipment. So furrow opener and ridges. So if the furrow openers was not maintain the depth of opening the soil, in that situation we need to adjust the furrow opener condition. Okay. So based on the soil condition only we need to select the furrow openers also. Next one is the seed metering and speed adjustment. Okay. So based on the farmer requirement we need to adjust the speed also, speed of the seed metering devices. Okay. So if the farmer required or if the seed rate required in particular area is more, in that situation we can go for the more amount of speed, otherwise we can go for the less amount of speed. Next one is the seed rate adjustment. Based on the seed rate adjustment only, based on the scientist recommendation to the particular fields, we can go for the seed rate adjustment also. Okay. So these are the summary of the today's lecture. We have discussed the seed drill calibration and also we have discussed the zero till drill and as well we have discussed the strip till drill also. Thank you.